Hello there, geometry students. I hope you're having a good day. I am ready today to go into our next section. Notice that we are on section 8.7. I've chosen to omit section 8.6, so don't be concerned that you didn't find it. It's not that it's not important, it's just that we have only so many days in the school year, so I'm trying to hit on the things that you're going to need the most. So we're jumping right into section 8.7. Now this talks about coordinate geometry. All right, in coordinate geometry, it means that we're going to be thinking about things on the coordinate plane. In other words, like when you would graph numbers, ordered pairs, and those type of things. So when we think about the coordinate geometry of circles, what we're thinking about is the way that you can graph circles on a graph. Before you've graphed lines in Algebra 1, circles are quite a step up from lines, but not too bad. I think you're going to find that it's pretty nice and simple process if you pay attention really close here in the next few minutes. All right, so we want to think about our definition of a circle. Now, most people, when you're in kindergarten or whatnot, you all are shown a picture of a circle and you say, oh yeah, that's a circle, and you know what it is, but technically it's the set of all points that are the same distance from what we call the center of the circle. Okay, so when we are thinking about the points that are the same distance from the center, we need to think about if you have a circle and you're thinking about that center point. All right, so you've got this center point that you're thinking about. Really, the thing that goes from the center to the end there, let's see if I can get this, there we go, on a segment. This segment right here would be the same measurement all the way around, and we've talked about the name of that segment before, and the name of that segment, that if you measured it, that would be the distance, you should all know is called the radius. And we're going to designate that as r in our formula when we get to that. So our radius is that distance from the center of the circle. Our distance formula is based off of the Pythagorean theorem, and it comes out to be, if you are on a coordinate plane, if you recall from your past, when you had x1, y1, x2, y2, and we had already talked about this distance formula before we even knew the Pythagorean theorem, but hopefully what you can see in here is a squared plus b squared equals c squared if you look at it in a certain way, and that's, so it really does come directly from the Pythagorean theorem. But what we want to do is we want to think about it, well, how does that relate to a circle? Okay, we said it's the same distance from the center. So r is our distance in our distance formula when we begin to think about a circle on a coordinate plane. If you've got an x-axis and a y-axis, got a circle on the coordinate plane, r is our distance. So we're going to use this formula and plug in r for the distance. Oops, don't need that yet. We want to think about what x and x1 is. If we think about the center of the circle as having an ordered pair of hk. HK is pretty standard in our math as far as being like an anchor point or a point that you base things off of. So H and K are going to be really important points. That's going to be our point. X1, Y1 will be the ordered pair HK. So we're going to go ahead and replace X1 and Y1, that ordered pair, with H and K. So what we can do in order to make this into an equation that's most usable is you can square both sides, to get rid of this square root sign. And now it really looks like a squared plus b squared equals c squared. That's for a whole other lesson in a whole other course, but we have this formula, and this is our formula that shows the equation of a circle with a radius of r and a center of h and k. And we're going to use that both to take a circle and figure out what the equation is, and then also to be able to graph a circle if we know what the equation is and we have it in this format. All right, so we're kind of at the bottom end as far as the equations of circles, but this is going to kind of take a break a little bit in most of Algebra 2, but then pick up again if you go into higher level maths. But for right now, you're getting this taste of the equations of circles. So let's apply that to a graphed circle. Okay, I want you to notice that I've got a graphed circle. It has a center, and there's a distance that we can think of as being how far away this center is from the sides of the circle. Now it would be pretty hard to count it this way because we're looking at each side of the square block as being 1 unit. This way we've got diagonals and they have a different measurement, so when we're thinking about the distances, we're really counting these type of blocks here. So when we count these types of blocks, 1, 2, 3, 1, 2, 3. The points on this circle are 3 units from the center, and we'll call that R. The center of the circle is literally, well, what is the ordered pair for this dot right here? And if you remember from your algebra, it's the ordered pair -2, 1. I've got that backwards. All right, I'm back and it's fixed. So h is -2 and k is 1, the ordered pair -2, 1. So what we can do then is you can take your r squared equals x minus h equation plus y minus k, and you plug in your r value, which is 3, and you plug in your -2 for h and your 1 for k. So 3 squared, -2 gets plugged in, and 1 gets plugged in. Remember our ordered pair -2, 1, coming for our center. And so what we have here is we have 9 equals x plus 2 squared, y minus 1 squared, and that's your actual answer for that. Now, a couple seconds ago when I started this, you saw that I had a mistake in there. I did stop and edit it as far as fixing it. So that's another good reason for you guys to use pencil whenever you do something, because then if you catch yourself, you can always go back and fix it without having to have crossouts and everything on there. So what I did is I went back and I virtually erased what was wrong and I fixed it for you guys, because we do need to understand the center, just like I had said, is -2, 1. So as you go through and you edit your own work, which is what you're doing when you are working on your homework or whatever, and you've got your pencil out, it does help you to be able to go back and do those edits. So I did not edit out the part where I said, oops, I've got that backwards, because that's also a teaching thing, is that you have to be confident enough that when you go back and you see that you've made a mistake, even in life, it's a little life lesson too, is that when you have made a little mistake, you go back and say, oh, I made a mistake, and you fix it, and then you move on. So just a little tiny blip, and in your watching of the video, it went by so fast, but just so you know that this is the correct way of doing it, and you're using this basic equation, r squared equals x minus h squared plus y minus k squared. All right, so we're going to use this situation again because that was with a picture, but this is with all words. We have a center of the circle and we have a radius, and we're asked to find an equation. So we need to take our pieces and then we're going to plug it right into this formula where it belongs. Our radius in the words here is given as 5, so you identify your radius. It's centered here at 3, 0, so you identify your h and your k. And then on top of that, then you start with your blank equation for the equation of a circle, and you just plug in your numbers. R is 5, h is 3, and k is 0. So 5 squared becomes 25. Y minus 0 is itself. And so y minus 0 being itself, you've got y squared. X minus 3 squared equals 25. And your final answer just looks like this. So especially if they give you a center and they give you a radius, these problems are really just a matter of plug in and do a little tiny bit of simplifying. Now the other thing we can be asked to do is go backwards and take an equation and then figure out the graph that goes with the equation. So what we need to do in this one is we need to begin to identify the pieces so that we can make a graph. So the first thing you need to do is you need to find R, you need to find H, and you need to find K. So our first thing is we have to remember that in our formula, this is supposed to be R squared. So if this is R squared, that means that R is going to have to equal the number that gives you 16 when you square it. R squared equals 16, so that means R has to equal 4. Hopefully that makes some good sense. That's a nice easy part. Our formula says x minus h squared. So it's in that formula, it is in that pattern, x minus h squared. So that means that h automatically is going to have to be 2. That one, once again, is very straightforward because it's in the exact format and you're just pulling the number out. Now what we notice here is it looks like we have a problem because our format is different. So what this really means is that y plus 1 is in the spot where we should have y minus k. R squared equals x minus h squared plus y minus k squared. So it's in the spot that's y minus k. So I'm just going to set it up here. Y plus 1 is in the spot where y minus k should be. So in this case, I want to solve for k. So if we remove y from both sides, we get the opposite of k equals 1. So k equals negative 1. So we found our r, we found our h, and we found our k. The one that's the trickiest, of course, is the one where the signs are backwards, but this is why it works and how we can find out that k equals negative 1. All right, so since we have that, we have our radius. We need to identify our center in order to make a graph. So our center is going to be 2, negative 1. So our center of the graph is going to be 2, negative 1. So if you're drawing a graph, the first thing you'll do is you're going to graph the ordered pair 2, negative 1. And the ordered pair 2, negative 1 in our graph is at 1, 2, negative 1. So this green thing is what you would do first. Now notice I already have a rough circle put in here, but this is actually the part you would do second. You would start at your ordered pair 2, negative 1. We know the radius is 4, so what you would do is you'd begin to count out 4. 1, 2, 3, 4, and you'd put a dot there. Count out 4, 1, 2, 3, 4, and you'd put a dot there. And then do that on all four sides and then begin to put in your sketch of the graph. It's kind of hard to do that. So I'm going to pull this aside real quick so you can see it happening. We'll get our lines in here. All right, here we go. I've got my y-axis and my x-axis. And so when I put in my ordered pair, I'll use the same color so we're color coded. 2, -1. Okay, there's my center. Then you pick out your points because you're looking at your radius of 4. 1, 2, 3, 4. Okay, all the way over here. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Oops, in order to get your points. Once you have your points taken care of, that's when you begin to sketch in your circle. Now, I had mine pre-done because sketching in the circle is kind of tricky, especially with the way this program works. So I had to kind of ad-lib a little bit. But you would, if you have a nice piece of graph paper, you're going to be able to sketch it in a lot better than this. Or even if you have your compass, then you would be able to just match it up, and then once you carefully sketch around, you end up with the circle like that. And it does have a center at 2, -1 and a radius there. Now my circle is not perfect, it's a little rough, but with hand drawing you kind of expect it to be like that. Okay, but the center, you can definitely tell the center, and then those anchor points where they are on there. Okay, all right, moving right along. Now, you know from your past history when you were given things like in Algebra 1, you were supposed to write equations y = mx + b in order to do an equation of a line. You might be given a slope and you might be given a point, and then you were supposed to write an equation, and we reviewed that earlier in the year. But we're going to use the same idea when we write an equation passing through the circle and find a missing piece. So what we need to do is we still need to be thinking about it has a center, and you can use this equation right here. Now the thing that we're missing on this one is a radius. And so since we are missing a radius, it makes it a little bit difficult for us to figure out exactly how this is going to look. And quite honestly, this one, if we were to graph the points, is not going to be convenient where we would be able to count the blocks, because this ordered pair and this ordered pair aren't on the same line, so it'll be like angled. So, you know, measuring it would be tricky. So we have to use this method in order to find out what our radius is going to be. So what we do is we plug in the things that we know. So the first thing that we know is we know h and k. So we're going to go ahead and plug in our h, and we're going to plug in our k. Now what about our x and our y? Now this is the general form of the equation. So there's like millions of x's and y's that'll work in here, but we're given an example of one of them. So we're going to temporarily plug them in as an example of an x and a y, because that's going to give us our radius that's going to be true for all of the points h and x and y. So I've got my 4 and my -12. 4 and -12. 4 and -12 are our x and y. Now we begin to simplify these. Keep, change. So 4 minus -3 is 4 plus 3, which gives you 7. Negative 12 minus 5, just to remind you, start at negative 12, keep going further to the left on the number line so you get more negatives, so you get to negative 17. When we multiply 7 times 7, we get 49. And when we take 17 times 17, even if you're just using a basic calculator, you do 17 times 17. Oh, wow, I just really messed that up. 17 times 17. That's where your 289 comes from. Okay. We add them together and we get 338. And then we can square root it. Now, I want to caution you right now, for our purposes, don't even bother trying to find any way to simplify this. Just leave it as the square root of 338, and you're going to see right now, even if it was something that you really could simplify easier, you don't have to simplify this at this point because we're using it as a step in the problem, and we're not actually looking for the decimal answer, so please don't make it into the decimal answer and don't simplify it. It's just going to make the work harder if you do that. So what we need to do then is we need to plug this r into our blank equation in order to find out what the general equation is that would have an x and a y in it to show all of the x's and y's. So you know your h and you know your k, you plug them in like normal. But now we're going to put this r in where r squared is. Okay? So we have the square root of 338 squared, x minus negative 3, because here's our negative 3, y minus 5. Now we know when we take a square root of something and you square it, they undo each other. They're inverse operations, just like when you add and subtract the same thing, you get that number back. So this becomes 338. Clean up your x minus negative to make it plus y minus 5, and this actually is your answer to this problem. This is why I told you don't even bother to try and simplify this, because if you tried to simplify this, you're going to end up with just a lot more work to do because it's going to disappear. Our square root sign is going to disappear anyway. So pretty nice, simple process. This is not something that you would want to try to graph and count. This is something that you would need to use the formula for. You have your h, you have your k, and much like when you solved an equation for y equals mx plus b, you plug in your known values to find that value that's going to come through with you. Your final answer gives you the equation to use so you could find all of those points that would make a circle. All right, so that's it. I hope that you were able to do well on this. Now don't forget to please fill out the video evaluation form. That is part of what you're doing every day. It's part of your responsibility. Next week I'm going to start counting it as part of the mandatory grade this week. Those of you that are doing it are getting a little bit of extra credit added into your homework grade because you're getting the hang of doing these, but do not neglect to fill in your video evaluation forms. That's super important. All right, I hope that you all have a really blessed day, and I will talk to you tomorrow.